Today's modern telescopes allow us to see distant objects by collecting and magnifying light, so that an image billions of light years away looks like it's just in front of us. Telescopes help us see distant galaxies, detailed structures of stars, and exoplanets and supernova, and even places you thought didn't exist. While the telescopes you can buy are probably some form of reflecting, refracting, or catadioptric telescopes, most large-scale telescopes will use mirrors in the design. The biggest reason lenses are avoided for such large telescopes are because lenses magnify images through refraction, which is an image because every color has a different index of refraction, leading to colors of light that don't focus to one point in your eye and translate into a mildly distorted effect, called chromatic aberration. Achromatic lenses can correct it to an extent, but introduce additional room for issues, not to mention how difficult it would be to manufacture multiple optically homogeneous and perfectly round lenses. Mirrors can be made larger and be supported more easily. Some telescopes are not just limited to the visible light spectrum, and even mirrors and lenses can be modified with different materials to interact with different parts of the EMR spectrum. Other than visible light, there are telescopes that magnify other parts of the EMR spectrum, including radio, microwave, infrared, ultraviolet, X-ray, and gamma-ray telescopes. These telescopes can either be ground-based or space-based, with space-based telescopes avoiding the blurring of Earth's atmosphere, along with being able to absorb wavelengths typically blocked by the atmosphere. However, space-based telescopes are incredibly expensive, difficult to repair, and risk failure of launch, which is why ground-based telescopes are still used despite the limited atmospheric window. In total, there are 29 active space-based telescopes. The Hubble Space Telescope, launched in 1990 by NASA and the ESA, has made some of the most impactful discoveries to astronomy. The Hubble telescope can see near and far, with the farthest observation being 9.6 billion light years away, a galaxy from when the universe was only 3% its size. The magnification works as a modified Cassegrain, where light hits the primary hyperbolic mirror and then reflects off the secondary convex mirror into a measuring instrument. Before Hubble was launched, the value of Hubble's constant was imprecise and the age of the universe a range of estimates. The distance of objects measured by Hubble allowed the creation of the cosmic distance ladder, which is used to precisely calibrate distances from Earth using apparent magnitude. Hubble measures the distances to a group of pulsating stars called Cepheid variables to calibrate other distances. Hubble also observed that in the core of galaxies, stars orbited at incredibly fast velocities, indicating a massive gravitational field and providing the first solid proof of black holes as the center of galaxies. Hubble has also observed multiple quasars, which have provided information regarding the age and formation of the galaxy. There are more than 1 million observations from Hubble, with 21,000 peer-reviewed papers and 1.2 million references to those papers, reflecting the long list of scientific achievements from this telescope. Some of which include, but are not limited to, first-time elements like boron detected in the early galaxy, first confirmation that supermassive black holes exist, first images of the collision of two astronomical objects, first to detect oxygen in the satellite's atmosphere, first images of a star's surface other than our sun, first visual evidence of planetary building blocks, first photographs of an asteroid with tails, first to detect water vapor plumes off of Europa, first space-based images of an asteroid breaking, first image of the first ever predicted supernova, farthest galaxy ever imaged at the time, farthest individual star ever imaged at the time, first detection of water vapor in an exoplanet inhabitable zone, first ultraviolet image of an exoplanet in formation, first detection of a possible moon around an exoplanet, and the first confirmation of the Andromeda Galaxy will collide with our Milky Way galaxy. Launched in 2021, the James Webb Space Telescope is the largest telescope in space. In contrast to Hubble, the James Webb Telescope magnifies light in the infrared spectrum and is recolored to show the light we humans can't actually see. It makes an orbit around the Lagrange 2 point, located 1.5 kilometers away from Earth, providing a farther view than the Hubble telescope. The James Webb Space Telescope's magnification process is similar to Hubble. Light first reflects off of the concave primary mirror, which is the largest mirror in a space-based telescope at 6.5 meters in diameter. Each of its segments is made of beryllium, but coated in gold to enhance infrared reflectivity. Then, light travels to the convex secondary mirror. Where the James Webb Telescope differs is at the tertiary mirror, which Hubble does not have. It's a convex rectangle that reflects light into a flat steering mirror and then into the measuring devices. Overall, this mirror allows a wider field of view, generally more arc minutes in each type of instrument compared to Hubble. Due to the large mirror, the James Webb Telescope would have been larger than the rocket that was designed to launch it into space. To combat this issue, the mirrors of the telescope were designed to be folded during launch and then unfolded in space. The James Webb Space Telescope has observed the farthest galaxy we know of, 13.4 billion light-years away, which means it would have been created when the universe was about 300 million years old. The existence of this universe doesn't currently fit with our known model of the Big Bang, since the size of J's GSZ13.0 is unusually large for a universe that formed so early. Current galaxy formations assumes that it takes much longer for galaxies to accumulate mass through star formation and merging. This makes astronomers explore other theories regarding our understanding of dark matter that forms galaxies, or the existence of population 3 stars, which are supermassive stars that would have had to form early on made of non-metal content, meaning they would burn quickly, end in supernovas, and then turn into black holes that would speed up the evolution of the galaxy. Another major observation of the James Webb Telescope is the evolution of a supernova, where it observed the same supernova in 3 different points in time in the same image, using a concept called gravitational lensing. This is when a massive celestial object causes light to bend around another object. A very large galaxy cluster was perfectly placed between us and supernova AT2022RIV, creating longer and shorter paths of light, with the longest path showing the oldest image and the shortest path showing the youngest image. It also helped magnify the distant objects like a natural lens. Without gravitational lensing, we would just see one image of the supernova at a time. The James Webb Space Telescope also excels at observing exoplanets and their chemical compositions. When an exoplanet passes in front of a star, most of the light is blocked except for the atmosphere, which will absorb or refract certain wavelengths of light. Since the James Webb Space Telescope measures infrared light, it excels in detecting molecules that could suggest biological activity. The next telescope to be launched by NASA is the Nancy Grace Roman Telescope in May 2027, with a field of view to 100 times of Hubble and orbit the L2 point, observing EMR between 0.5 and 2.3 micrometers. But we can't forget about some of the Earth-based telescopes either. The Keck Observatory is located in Hawaii and can see further into space than the Hubble Space Telescope. The Keck Observatory holds 2 telescopes at an elevation of 4,145 meters, which provides an excellent viewing area. These telescopes observe infrared and visible light and use an advanced Cassegrain design with 3 mirrors. This telescope is considered to be one of the most productive land-based telescopes, with more than a quarter of observations from U.S. astronomers being made here. Many new, very large land-based telescopes are in the process of being built as well, such as the Extremely Large Telescope, which is due to be built in 2027. Its mirror will be 978 square meters, which is almost 40 times larger than the James Webb Telescope's mirror. It will be an optical infrared telescope capable of collecting 100 million times more light than the human eye. Overall, telescopes help us observe the celestial objects in the universe and extrapolate the nature of the cosmos, and even helps us predict what happens at the end of the universe when Mr. Samji begins his comedy career.